Okay, so let's evaluate our function for each of these different values of x. All right, so down there at the bottom you see h of negative 6. Well, I know how to do this. I just find the value, I find out which one of these pieces I'm going to use when x is negative 6. Well, let's see. X is negative 6. So when x is less than or equal to negative 2, then I use this function. Okay, so x equals negative 6. I plug negative 6 in here. Negative 6 plus 4 is negative 2. And the absolute value of negative 2 is 2. So h of negative 6 equals 2. And in fact, I can see that on my graph as well. If I let x be equal to negative 6, here's where x is equal to negative 6. And this value right here, that's where y equals 2, or the value of the function is equal to 2. What's h of 0? Well, let's see. 0 is between negative 2 and 2, so I would use this function. Well, when x is 0, the value of my function is going to just be negative 3. It's just a constant value. I don't actually have an x to plug into. When x is equal to 0, the value of my function is negative 3. And again, I can see that on the graph as well. When x is equal to 0, that's this value right here, the function is right here, where y is equal to negative 3. What's h of 1? Well, when x is equal to 1, let's see. 1 is also in between negative 2 and 2, which means I would use this value of my function again, which is just h of x equals negative 3. And once again, I can see that on my graph. When the x value is equal to 1, which is right here, the value of my function is negative 3. What's h of 4? Well, let's see. 4 is greater than or equal to 2, so I'm going to use this piece of my function right here. I take x equals 4 and I plug it in here. Square root of 4 is 2, and 2 minus 1 is 1, so h of 4 is 1. And again, I can see this on my function, as on my graph as well. If x is equal to 4, 2, 3, 4, then the y value, or the value of the function, is equal to 1. Now we come to, what do we do for these values here? H of negative 2. Well, let's see. H of negative 2. I'm not going to use this one because this is only for values of x that are greater than negative 2. This is the one I'm going to use when x is less than or equal to negative 2. So I take my x value, negative 2, I plug it into my function here. Negative 2 plus 4 is positive 2. The absolute value of positive 2 is 2. So h of negative 2 is 2. And the way I represent that on my graph, since h of negative 2 is equal to 2, in other words, I want h of negative 2, I want the value of my function on the graph to be this value up here, and not this value down here. And so the way we represent on the graph for these values right here, which are called the breakpoints, that's the value of x at where the graph has this big break in it, we represent it like this. Since it's equal to absolute value of x plus 4 when x is less than or equal to 2, well, right here on this breakpoint, I'm going to put a big colored in circle right there on that end point of the graph. And down here, I'm going to put an open circle to indicate that when x is equal to negative 2, this is the point on the graph and not this point down here. So let's see if we can do the same thing for this breakpoint over here where x is equal to 2. So when x is equal to 2, the value of my function, h of 2, let's see again, I'm not going to use this middle one because that's only for x values that are less than 2. This is the one I want when x is greater than or equal to 2. So when my x value is equal to 2, then I would plug it in here. I would get the square root of 2 minus 1. The square root of 2 is approximately 1.4. So 1.4 minus 1 is approximately 0.4. So h of 2 is 0.4. And again, I want to indicate that on the graph by coloring in the value of the function, by coloring in the graph right here, and putting an open circle down here. That lets me know that when x is equal to 2, this is the value of the function. This is the part of the graph that represents the function and not this part down here. Now, why don't you go back to example number 2 and see if you can fill in the proper open circles and colored in circles on the graph of, in example 2, that graph of g of x.